Previously, we had said that the grouping method would allow us to reverse the FOIL process when the FOIL problems had the O and the I as unlike terms. If the O and the I parts are like terms, then we saw that very often the answers we would get would be trinomials. So we would need a factoring method that allows us to start with a trinomial and break it apart, undo the FOIL process, and get a final answer that would be a binomial times a binomial. The AC method is one way in which to do so. This allows us to build an answer rather than one of the other popular alternatives, which is to guess and see what might work out. So rather than guessing and trying to create our answer, we take as much of the guesswork out of things as possible and try to build the answer using our 4 steps presented here. When we refer to the AC method, we're referring to the A as the coefficient of our squared term at the front usually, and the C as the coefficient of our last term, which is most often just a regular constant term, but can also sometimes be a squared term as well. And it is usually the last term, but again, we want to watch out for them trying to trick us by having an unconventional arrangement of the terms. Things written in a normal fashion would basically fit the structure ax squared plus bx plus c. So the AC method refers to the number a and the number c that appear in our specific problem. In this first example, since we do not have any other number in front of our x squared, we consider the a as 1, and the c is a positive 6. So the first step says find AC, meaning a times c. 1 times 6 is 6. Step 2, I need 2 very special numbers. They have to fit 2 requirements. Blank times blank is going to give me this number that I figured out from my first step. Blank plus blank is going to give me the number that shows up in the middle term. So basically I want to fill in the blanks. What times what gives me 6? Well, the first possibility is the no-duh possibility. 1 times 6 gives me 6, but 1 plus 6 does not give me that middle number 5. So instead I've got to look for another possibility. Well, 2 times 3 gives me 6, and 2 plus 3 gives me 5. So the 2 special numbers that I need to move on are going to be a positive 2 and a positive 3. So I'm going to use those 2 special numbers when I move on to my third step. What I'm going to do is I'm going to keep my first term. I'm going to kick out my middle term and put in those 2 special numbers, a plus 2 and a plus 3, positive 2, positive 3. Those 2 special numbers are going to get the same variable stuff that did show up in my middle term. My middle term had an x. So my positive 2 gets an x and my positive 3 gets an x. The last term of my problem, the plus 6, is going to stay the same. So that what we've done in these first 3 steps is break things apart from 3 terms into 4 terms. And when we have 4 terms, as we said in the previous video, we can use our grouping method to work out the rest of our answer. So we just say step 4, factor by grouping, and what we mean is that we've got to go through those individual steps where we would group the first pair, group the second pair, put a plus sign in the middle, factor the first pair of parentheses, factor the second pair of parentheses using our GCF idea. We'll see that we've got that x plus 2 in common in both of those groupings, so we can yank the x plus 2 out to the front, and what we would have left over is an x and a plus 3. So our other half of the answer, x plus 3. Again, this is all designed to reverse the process of FOIL. If we take our answer and FOIL it, it should send us back to our original polynomial, and it does in fact do so. This is where the real power of being able to check our answer comes in, because we have a much more complicated set of steps to work through. We have more places that we can make a mistake. Most significantly, we need to make sure that we've got the correct two special numbers that end up replacing our middle term. If we don't have the correct two special numbers, we're not going to get the correct final answer. So we've got to be very careful, especially with that step. To look at another example here, let's consider something that starts out with a number other than 1. So in this particular problem, we start by finding the a and the c and multiplying them together. The a is a 2, the c is a positive 10. 2 times 10 gives me 20. So again, the important part, I'm looking for two special numbers. They have to fit two very specific requirements. What times what gives me the 20? Blank times blank gives me the 20. Blank plus blank gives me the 9 from my middle term. So I have to fill in the blanks just right. Well, we can consider the possibilities, and in fact, just to kind of jot things down off to the side, we can consider the possibilities starting with the no-duh versions, the 1 and 20. 1 plus 20 does not give me 9. The 2 and the 10. 2 plus 10 does not give me 9. 3 doesn't work. 4 and 5. 4 times 5 gives me 20. 4 plus 5 gives me 9. So these are in fact good to go. I would like to have a 4 times a 5 and a 4 plus a 5. And so when I put those into play, we're removing our middle term. We're going to put in the two special numbers that we came up with, and that is a positive 4 and a positive 5. So trying to highlight those with the blue color there. These two special numbers do also need whatever variable stuff appeared in our middle term. Well, that's just an x. So the positive 4 does get an x, and the positive 5 does get an x. The first term and the last term of our problem, the 2x squared and the plus 10, are going to still be the first and last terms. By creating these two special numbers, I now have 4 terms, and I can work through my grouping steps. Grouping steps kind of already planned out here, that I'm going to put my first pair inside a set of parentheses, and I'm going to put my second pair inside a set of parentheses, and I'm going to have a plus sign in between them. From that first pair, we can break off a 2 and an x, and that will leave us with x plus 2. From the other pair of parentheses, we can break off a 5, and that will leave us with an x plus 2. So in our final answer, we should have the x plus 2 as half of our answer, and then the other half of our answer would come from covering up the x plus 2 and seeing a 2x plus 5. Foil that out and make sure that it sends you back to your original polynomial, and in fact it does. So we can be confident that we have the correct final answer here. (3x squared minus x minus 10). We have a trinomial. We're going to need to use our AC method, so we need to pick out the a and pick out the c. The a is the first number that is in front of my x squared, so that's a 3. My c is going to be the last number as far as the traditional way of ordering our polynomials. So the last number that we've got is going to be a negative 10. I'm going to need to use the negative with the 10, and that'll give me the number negative 30. So, blank times blank gives me a negative 30. Blank plus blank is going to give me, well, I need to know what the middle number is. Middle number here has a negative also, but there's nothing else that shows up. So that does mean the invisible 1 needs to be made visible again. That middle number is a negative 1. Blank times blank gives me a negative 30. Blank plus blank gives me a negative 1. Because of the signs here, we can say what would basically have to happen is that we have 1 negative and 1 positive. But we also have to worry about the numbers themselves, so we can go through a list, 1 and 30. Now, no matter which one of those is the negative, those are just too far apart from one another to get me to blank plus blank equals negative 1. I need numbers that are much closer together. But again, if I don't automatically have an idea of what could work, I can make my way orderly through the different possibilities. 4 doesn't work, so I jump to a 5. Now these will work, but I have to have just the right one negative and just the right one positive, so that blank plus blank is negative 1, which means that we would have to have a 5 as our positive, and we would have to have the 6 as the negative in order for things to work out properly. Now that we have the correct pair of numbers, we can go ahead and replace the middle term. So the 3x squared will stay. The middle term is going to be removed. We're going to kick it to the curb, and we're going to put in the positive 5 and the negative 6. And when we do, we're going to have to put in the variable from the middle term with each of our special numbers. So the middle term had the variable x. Our positive 5 is going to get an x. Our negative 6 is going to get an x. And we're also going to have our last term, our negative 10, our minus 10, still showing up as well. Now that we have 4 terms, we're ready to work through our grouping steps. So our grouping steps begin with grouping the first pair together inside a set of parentheses, grouping the second pair together, and in our examples, this is the first time that we see that when we group the second pair together, the second pair starts with a negative or a minus 6x. So that's going to be in that second set of parentheses. And again, we also said all along that we need to put a plus sign in the middle. And then we can move on to factoring out the greatest common factor from the first set of parentheses. We don't have a number in common, but we do have an x. From the second set of parentheses, since we're expecting to see a positive 3x followed by a plus 5, we can use that expectation as a guide, especially when things maybe get a little squirrely on us. if I'm expecting this negative 6x to become a positive 3x, then I'm going to need to pull a negative and a 2 out to the front of this next set of parentheses. Negative 2 times what gives me negative 6? Well, there's my positive 3, and it would have to have an x. And let's see if the plus 5 also matches up. Negative 2 times positive 5 gives me a negative 10. Yeah, that matches up with what we have inside that second set of parentheses. So, little hint, little guide, helping us out here. And so we can come out with our final answer having the 3x plus 5. And the other factor, the other half of our answer, the x minus 2. If we FOIL this out, we can check to make sure everything is in fact good to go, and it is. The previous examples all had a single variable, but at the beginning of our discussion, we mentioned the possibility that the A and the C didn't necessarily come from just straight up what we might have expected based on those earlier examples. That the A does come from something being squared at the front, so a squared term at the front, but that the C could come from a squared term that shows up at the end, like this example. So, despite the fact that we've got two separate variables that appear in this problem, we're going to go through the steps that we've been using in all the other examples, and we're going to see that those steps will automatically get us the answer that we need. There's nothing more complicated about this example than the last one that we worked out. We have a trinomial. We need to use the AC method. The A refers to the number appearing in the first term that has the x squared, and that is 1. The C refers to the number appearing in the last term that happens to have a y squared, so the number is a positive 10. 1 times 10 is 10. We need two numbers that will multiply together to give us 10, and that will add up together to give us the middle number, which happens to be a negative 7. For all of this to work out properly, blank times blank equals a positive, blank plus blank equals a negative. Well, the only way that we can get a negative showing up in this statement and a positive showing up in this statement is for us to have both of the numbers that we need being negative. Then we can go ahead and start considering the possibilities. Again, the no-duh version, 1 and 10, not going to fly. 2 and 5, those fit the bill. They both have to be negative, so negative 2 times a negative 5, negative 2 plus a negative 5, those both fit the statements that we had. So the two special numbers that we need to use are going to be the negative 2 and the negative 5. We keep the first term. We put in the negative 2. We put in the negative 5. Each of those special numbers needs the variable stuff that appears in the middle term. In the middle term, we have both an x and a y, so the negative 2 is going to need to have an xy. The negative 5 is going to need to have an xy. And we keep the last term. In doing so, we have created 4 terms. When we have 4 terms, we try to use grouping to work through things, meaning that we would group our first pair of terms together, and we would group our second pair of terms together, and we would put a plus sign in between them. Then we would look at each set of parentheses separately and try to find a greatest common factor. In the first set of parentheses, the greatest common factor would just be the variable x, and that would mean that we have left over x minus 2y. Here again, we can use this as a guide, as a hint. I'm expecting to have an x. Right now, I'm looking at a negative, a 5, an x, and a y. Well, that's even quicker than what we'd seen before. If all I want to see showing up in parentheses is an x, then I am going to need to have removed the negative, the 5, and the y out to the front, so that only the x will show up. And let's make sure that the other part of that would also work out properly. Negative 5 times negative 2 gives me positive 10. Y times y gives me y squared. So the rest of that does in fact work. And so half of my answer is going to be the x minus 2y. And the other half of my answer is going to be the x minus 5y. If we go ahead and FOIL that out, we can check to make sure that we end up with our original polynomial, which we do, so we can be confident in our answer. Now, one final comment to make, now that we've seen a lot more examples of the grouping, when we work through our grouping method and also when we work through our AC method, though in all of our examples we've done things in exactly the same sort of fashion, you might be wondering if it's allowed that you switch these so that the first part of your answer is the x minus 5y and the second part of your answer is the x minus 2y. And that is totally allowed. And in fact, depending on how you're working your steps, you may definitely come up with that kind of answer that would be traced back to if you had written your special numbers in the other order. Then you would have ended up eventually with an answer that looks a little differently from what you've seen in these examples. So going back even to the previous example here, we could have just as easily had the x minus 2 showing up first, followed by the 3x plus 5 showing up second. As far as a correct answer, it doesn't matter which order those factors appear. And so you can think of it more simply. 3 times 4, 4 times 3, they give us the same answer. So the order that these factors appear doesn't affect our answer. I just need to have them. So I need to have an x minus 2y and I need to have an x minus 5y. If I've got those two factors, then I've got the correct answer that I need. Doesn't matter if it looks like this one or if it looks like the flip-flop.